Hello Math 2 and welcome to week 7 where we're going to be working on the product and also the quotient rules for finding derivatives. Before we do that, we actually have a couple of rules from logarithms that we're going to be using, so let me just review those. Hopefully you saw these in algebra. If not, that's okay because they're pretty easy. The first one is if you have a logarithm of an a times b. Then you can separate that into two logarithms and then you just add them together. So when we go to do derivatives, basically if you have a more complicated problem like this, you can actually break it up into two easy problems like this. And then there's one for division. So if it was a divided by b, then it's going to look exactly the same except the plus is going to turn into minus. So then it's the natural log of the a minus the natural log of the b. And two more. One is if you have natural log and then this is raised to some power n, then you can take that exponent n, bring it in front and multiply. And then the last one is if you have log with some base b of x, then you can change that into ln of x over ln of b. So those themselves are not derivatives, but they will help us because you're basically taking something more complicated and then turning it into something that's easier. And so I went ahead and added them to my little 3x5 card right here because we do use those quite a bit. So now they're in my memory. Okay, then oh, you know what? There's another one. This one is actually calculus. And that is if you have the natural log of x function and you take its derivative, then it's very simple. It's just 1 over x. So whatever this is, if this is a smiley face or a square root of x, whatever it is, you just put it in the denominator like that. And that's the derivative. Okay, so now let's start doing some examples with the natural log and the derivatives. So for example number 1, if it was natural log of 2x. So that is an example of this one right here. So this is going to be the 2 and the x, this will be the 2 and the x. So I can rewrite this as the natural log of 2 plus the natural log of x, because it's understood that this is multiplication, so you can break it into two simple logarithms. And then when you take the derivative, so let me just say this is the function y equals, I should have said that at the beginning, there we go. Then the derivative. Well, natural log of 2 is just a number, so the derivative of just a constant is 0. Like I have stored in my memory right here, the derivative of a constant is 0. So 0 plus, and then this is 1 over x. So that means that the answer is just 1 over x. Okay, that one's done. Then for number 2, what if it was the function the natural log of x squared? So this is where I could use this one. So this right here is the squared. Then just put that in front, so the 2 will go right there. So first, just rewrite it. So this is not the derivative, this is just a rule from logarithms. So rewrite it in a simpler form like that. And now take the derivative. When you do, the 2 will just stay there. And then the derivative of natural log of x is 1 over x. And then since 2 times 1 equals 2, I could just simplify that as 2 over x. And then circle my answers. Then for number 3, so for example number 3, how about y equals a 7 times the natural log of 12 divided by x. So the 7 can just sit there in front, and then for divided by, I'm going to use this rule for logarithm and rewrite it with subtraction in between. So first of all, I could rewrite this as y equals. The 7 can stay there, and then I'm going to put brackets because it has to be 7 times the whole thing. And then it's natural log of the top minus the natural log of the bottom. Okay, that's the algebra part. Now for the calculus part, take the derivative. So the 7 stays there, and then this is just a number, so the derivative of that is 0. And the derivative of natural log of x is 1 over x. And now we're done taking the derivative. I should just simplify my answer. So 0 doesn't really count for anything, so that can be gone. And then we'd have 7 times 1 on the top, and then just keep the negative sign there. And we're already done with number 3. With number 4, and I got this one out of the homework, so what if you have e to the x? We've done the derivative of e to the x, haven't we? Okay, if we haven't, that's okay, because it's very easy and fast. The derivative of e to the x is the easiest one there is. The question is the same as the answer. The derivative of e to the x is e to the x. So I suppose that I should include that somewhere. I'm going to put it right here. The derivative of e to the x is just e to the x. It's the only function that does that. All right. Now what I really wanted to do on this one is say, what if the function was e to the x plus e to the 2? Well, it turns out that the answer is the same, because the derivative of e to the x is e to the x, and e to the 2 is just a number. And when you take the derivative of a constant, that's 0. So this would say plus 0, and that means the answer is just e to the x. Then for one that is similar to that, but does take a little more work, so this is going to be example number 5. So what if instead of e to the x, it was some other number like 2 to the x? So the derivative of e to the x is e to the x, but it's not exactly the same for 2 to the x. So what I can do is I can take the natural log of both sides. Doing the same thing to both sides of the equation is perfectly fair and legal. And then on this side, this is the rule from the logarithms that looks like this. You can take that exponent, bring it in front, and multiply. So the x can go in front, and then it's going to say natural log of 2. Now when I take the derivative, the derivative of the natural log of y is going to be 1 over y. And then for something slightly different, and that is on this side, I never said y prime. So basically, this has two things. It has the natural log, and I take its derivative, that's 1 over y. It also has the y function, and I need to take the derivative of that. So then you multiply with y prime. On the other side, since this is multiplication with a number, you just say take the derivative of x, which is 1, and then the natural log of 2 is going to stay there. And then I want to solve for y prime. So just multiply both sides by y. These are going to cancel, so it's going to say y prime equals. And then this would be the natural log of 2. And from the very beginning, if you look at the black part, it says y equals 2 to the x. So then just replace this y with 2 to the x. And usually that's put in the front rather than the back. So then it's 2 to the x times natural log of 2. Okay, so the next thing is I think I can still use this. I still got some room. And this is also coming from the homework. So use a calculator. Oops, calculator to solve. Let's see. I'm just going to make one up here. So let's go with y equals the natural log. And then take a look at the graph. So there goes the natural log function. And then we'll go with y equals like e to a negative x. And then we should be able to see that the two intersect right about there. And then I want to see where they intersect. So use a calculator to solve when does, and my functions were, when does the natural log of x equal e to the negative x? Okay, so I have them graphed. And now just go right here to calculate. So go second, calculate. And you guessed it, it's number 5. Where do they intersect? And then you just need to move the cursor until it gets close to where they intersect. As long as it's fairly close, the calculator will find the answer. Now it's going to ask you to, and I don't know why, but it's going to ask you 3 times, where do you think they intersect? Okay, right there. Hit enter. Now it says, for your second guess, where do you think they intersect? I still think right there, so I hit enter again. And then what's your guess? Well, my guess has not changed. It's still right there. So it turns out that x equals a 1.31. X equals a 1.31. All right, now we're finally on to the product rule and the quotient rule. So the product rule goes like this. So product means multiplication. So if you have 2 things that are being multiplied, and I just like to keep it simple, like an A and a B, then basically the rule goes, you are going to take the derivative of the A and you are going to take the derivative of the B, but you can only do one at a time. So start with the A, take the derivative of A, and whatever the B is, just copy it down. Next it goes plus, now leave the A alone, and then take the derivative of the B. So that is the product rule. And as you can see on my little memory card, it's already full on this side. So then what I did is I added the product rule right here, and then in a moment we'll do the quotient rule. Oh, and I also added the derivative of natural log of x as 1 over x because I didn't have enough space on the other side. Okay, so then for some examples using the product rule, this is going to be example number 7. How about if y equals, and it's the product of 6x cubed times x squared minus 9. Now with this particular problem, I could actually just multiply it out and then take the derivative using the power rule. But there's going to be many times when you can't do it that easily with algebra, so you do need to use the product rule. So this is the A and this is the B. So sometimes when you start using the product rule, you might want to write it underneath like I'm going to do in red. So take the derivative of A and leave the B alone, plus leave the A alone and take the derivative of B. My primes sometimes are really big and sometimes small. Need to be more consistent. Or just chill out and be all right with it. Okay, so we're going to use the derivative right here, which means the 3 goes in front and multiply, which is going to be 18. And then subtract 1 from the exponent. So that's the old power rule. So that's the A prime. Now just copy down the B exactly as it is. X squared minus 9x. Oops, sorry, minus 9. And then it goes plus. Now just copy down the A 6x cubed. And now take the derivative of the b. Well, the derivative of negative 9 is 0, so that's already gone. And the derivative of x squared, you put the 2 in front and then subtract 1 from the exponent, and then it's done. So now we just need to simplify the answer. So if you distribute this 18x squared times the other x squared, that's going to be 18x to the fourth. And then when you distribute it to the 9, I need 18 times 9. Of course, everybody could do that in their head, except I don't want to mess it up, so I'm going to go 18 times 9. Oh yeah, 162. And it had a negative, so negative 162x squared, and then multiply these two, so that's going to be 12, and then 1x with 3 more, so I've got 12x to the fourths. And then finally, this has x to the fourths, and this has x to the fourths, so combine those. And an 18 plus a 12, that would be 20 plus 10 is 30. X to the fourth, and then minus the 162x squared. And once I've combined all of the like terms, I'm done. All right, then for another product rule, for number 8. So this one is going to be the e function, and then that's good news because the derivative of e to the x is just e to the x. And then it's multiplied with 2x squared plus 7x. And then use the product rule. So at the beginning, you might want to write down, like I did in red, this is the a, and this is the b. And then write down the product rule, a prime times b plus a times b prime. And then after a while you get used to it and you don't need to write down this part anymore. So starting with the derivative of the first one. So the derivative of the e function is just the e function. And then just copy down the b to x squared plus 7x. Now just copy down the a function. So that's going to be e to the x. And now take to the derivative of the b. So when you do the power rule right here, put the 2 in front and multiply, that's going to be 4. And when you subtract 1 from the exponent, it leaves 4x. And over here, the derivative of x is 1, so that means the derivative of 7x is just a 7. Now with the other one, I multiplied it out to combine like terms, but with this one, it has e right here, and it has e right here. So this one, to simplify it, I'm going to factor out e. And then what does it leave? Well, it leaves 2x squared, and there's no other x squares. So as far as x squares, that one's done, 2x squared. And then this has 7x plus 4x, and a 7x plus a 4x is an 11x. And then finally, there's the plus 7. And then it's finished. And for example number 9, using the product rule, how about if it is y equals x to the fourth times the natural log of x. So this time I'm going to do it without writing down this red part and just go ahead and do the product rule. So take the derivative of first one first, and the derivative of this is going to be, put the 4 in front and then subtract 1 from the exponent. And then leave the natural log alone. Plus, leave x to the fourth alone, and now take the derivative of natural log of x, which is 1 over x. And as far as simplifying, all I need to do is simplify this little part right here. This x on bottom will cancel one of these, leaving x to the third. And then this part can't be simplified, so you just recopy it, and then circle it, and say Bob's your uncle. Okay, now on to the quotient rule. in the quotient rule, as soon as I get my piece of paper here, so quotient means you're dividing. So if you have an a divided by b and we're trying to find the derivative of that, well, since the question was a fraction, the answer is going to be a fraction. And it actually starts off just like the product rule. Take the derivative of a and then leave the b alone. But instead of plus, this one has minus. Now leave the a alone and take the derivative of b. And then finally, on the bottom, there's b squared. Later on, when we've covered the chain rule, I can actually prove where this comes from, but for now, we're just going to use it. So this must be example number 10, since the previous one was 9. So this one is a quotient y equals x divided by x plus 1. And like it did previously in red, you could write out the rule each time, or you could just start doing it. So I'm just going to start doing it. So I know that the answer has to be a big fraction. So there's my big fraction bar. Also, the b just has to be squared. So I can actually do the bottom part. That's easy. Just put parentheses around it and square it. Okay, now start with the a. The derivative of x is a 1. And whatever the bottom is, you just copy it down. Then the quotient rule goes minus. Now whatever the a is, just copy that down, x. And whatever the b is, the bottom, take its derivative. And the derivative of the bottom, well, the derivative of x is 1. The derivative of plus 1 is plus 0, so that means it's 1 plus 0, or just 1. And this one does need to be simplified just a little bit. So the general rule is combine like terms. Like right here, there's an x, and then this is minus x. So they actually cancel. And then there would be just this 1 times 1. So on the top, there's only a 1. And on the bottom, don't multiply it out. Just leave it as x plus 1 being squared. And then circle it. That one's done. And next, example number 11, quotient, and the top of it is going to have x squared plus 7, the bottom 2x plus 5, and then find the derivative. So I know that the answer is going to be a big fraction, so might as well start with that. Also, the bottom needs to be squared. So I'm just going to go ahead and do that. And then for the top, you start on the top and take the derivative. Well, the derivative of x squared is 2x, and the derivative of 7 is 0. So that means all I have is a 2x. And whatever the bottom is, you just copy it down. And then the quotient rule goes minus. Now whatever the top is, just copy that down. X squared plus 7. And now whatever the bottom is, take its derivative. Well, the derivative of 2x is just a 2. Derivative of 5 is 0, so we've got 2 plus 0, or just 2. And then simplify. So let's see, the bottom, do not multiply it out because that would actually make it more complicated. It's better to just leave it like that. So just copy that down, we're done. And then on the top, let's see, this, when you distribute, that is a positive 4x squared. When you distribute this, that's going to be minus 2x squared. So this is 4x squared minus 2x squared is 2x squared. And then distribute, and this is going to be 10x, and there's no other just x terms, so that has nothing to combine with, so that's just going to be plus 10x. And then when I distribute this 2, well, 2 times 7 is 14, but keep in mind there's this minus sign, so then it's actually minus 14. And then number 11 is done. And then we need to do one with the natural log. This paper is getting a little bit smudged. Let me get a fresh paper. So one with natural log. So this will be number 12. So what if the function is the natural log of x over x plus 12? So it is the quotient rule. I like to just write the fraction down and go ahead and do the squaring part, because that way the bottom's done. Now for the derivative. So take the derivative of natural log, which is going to be 1 over x. Whatever the bottom is, you just copy it down exactly as it is. Then it goes minus. Now whatever the top is, you just copy that down. And then take the derivative of the bottom, and the derivative of x is just a 1. And of course, derivative of 12 is 0, so this turns out to just be a 1. And then this one I do need to simplify, especially since this has a fraction within a fraction. So that's known as a compound or a complex fraction. And all I really need to do is to get rid of this x, I need to multiply by x. But if I multiply this term by x, then I also have to multiply this one by x, and I also have to multiply this one by x. So then what do we have as our answer? Well, those are going to cancel, which means it's just 1 times this. So 1 times it doesn't change it. It's still x plus 12. And then minus this x times this natural log. And usually this red x is put in front so that you don't think of it as x times x, because this one is inside the natural log. So you can't just multiply the x's. So this red x, I'm just going to put it in front of the natural log of x. And then once I just recopy the bottom, then I'm finished with this problem. There's nothing else to do. That one is complete. Okay, so then there are some other applications or things to do once you do take the derivative. And this one is in the homework, and it's also on the problem set. So for example, number 13. A town's population is growing exponentially. And then as soon as you see that word exponentially, that means that we're going to be using the PERT formula. So the story is that in 2019, there were 12,000 people. And then in 2022, there were 18,000 people. And in case you can't tell, I made this up myself. All right, so that means that for the PERT formula, then this has to be the beginning population. So this is the 12,000. The P is the 12,000. The amount of people after some years, that's the A. So this is going to be the 18,000. And if you subtract these two, that's going to be 3 years. So substitute a 3 right there. So the A gets replaced with the ending amount of people, 18,000. The P is the beginning amount of people, 12,000. And then it's E. And the R is not given, so for right now I just put the letter R. And then this is the years, and this is 3 years. And then we need to solve for R. So the first thing to do is divide both sides by the 12,000. And these are going to cancel. The 3 zeros will cancel the 3 zeros. And I'm not even going to reduce this because I next need to take the natural log. So take the natural log of both sides. And since I'm going to end up typing this in a calculator anyway, then I don't really need to reduce it. And then take the natural log on the other side. And then the good news is that the natural log and the e cancel each other out. So on this side, all that's left is the r times 3. And then in order to solve for r, just divide both sides by 3. All right, then it's time to use a calculator. So if you have the natural log, so make sure you're using the ln down here, the natural log of 18 divided by 12, put that in parentheses, and then divide by 3. So that means that the growth rate is 13.5% per year, or as a decimal, r equals 0.135. So the r equals a 0.135. And then that means that the function in general for this town is you put the beginning 12,000 people, and then e and the 0.135 times t. Okay, that was the algebra part of the problem. Now we're going to do the calculus part of the problem. So let me just transfer that function to this paper. Number 13, we got a equals the 12,000 people, and then it's growing exponentially. The r was a 0.135 times t. So then find a of 4 and also a prime 4. So find the function when you plug in a 4 and also the derivative when you plug in a 4. So a of 4 is going to be the 12,000 e to the 0.135 times 4. And then that's 12,000, and then put second, so make sure you use the e over here, so second e, and then 0.135, 5 times 4. And so that means that their town has grown to 20,592, and since we're not talking, we are talking about people, we are not going to have 0.08 of a person. So then that's people. And this part means 4 years later. So you actually have to go to the beginning of the story. The beginning of the story was 2019. So if you add 4 years to that, that's 2023. In 2023. Now for finding the derivative. Well, this is going to use something just a little bit new, but don't worry because it's very easy. So first of all, the derivative of the e function is just the e function. So you just copy the whole thing down. That is the easiest derivative there is. Times. And then here's the small new thing. And that is I took the derivative of the e function is itself. But I never took the derivative of this. So now I need to take the derivative of this. Since t is the variable and it's to an exponent of 1, then its derivative is just going to be 1. And that means that it's going to be 1 times this decimal. And then I just bring down that decimal and multiply. And then I plug in a 4. So it basically means it's the exact same thing as this, because I'm going to plug in a 4. I just have to multiply by this decimal. So that means that it's just going to be that same answer, 2592, because that's what I got when I plugged in a 4 for this part, and then just multiply with this decimal. And basically what that's saying is, okay, yes, there are 20,592 people in that town in 2023, but how fast is the town growing? Well, it's growing at a rate of 13.5%, but how many people is that? Oh, okay, well, just take that decimal, or excuse me, take that number 20592 and multiply it with the decimal 0.135. And so then that equals 2,700 and, okay, that is almost a whole person, 0.92. So that's going to round the 79 up to 80. So that's how many new people. So the town has grown from 12,000 to 20,000 by the time you get to 2023. And then this is how many new people. So this is the new people in 2023. So you can not only tell how big is the town now, but how many new people do they have. Okay, then we're at 36 minutes. We need to do 2 more. And these are not word problems, but they do use derivatives. Number 14 is going to be, how about if y equals a 2x squared plus 3x times of 5x minus 2. Then put the derivative equal to 0 and then solve that. When is the derivative equal to 0? So this one goes back to the product rule. So take the derivative of the first one. The derivative here is going to be 4 times x. And the derivative of this is just plus a 3 because the derivative of x is 1. And then just copy down the b, the 5x minus 2. And remember that the product rule has plus. This time, just copy down this problem, the 2x squared plus 3x. And then take the derivative of 5x minus 2. And the derivative of 5x is just a 5. That's a 0, so it's just a 5. And then set it equal to 0. So first thing I need to do is multiply this out. So distribute the 4x. So that's going to be, first of all, 4x times 5x will be 20x squared. Then a 4x times a negative 2 is minus 8x. And then distribute the 3. And this is going to be plus 15x. And 3 times a negative 2, that's a negative 6. And I also need to distribute this 5. So that's going to be 5 times 2, so that's going to be plus 10x squared. And then this is going to be plus 15x. So that means in total, when you add these two together, that's going to be 30x squared. And then as far as the x's, there's 15 positive and 15 positive, so that's 30x, minus 8. And 30 minus 8 is 22, so plus 22x. And then the only thing that's left is a minus 6. And I try to make these videos stay under 45 minutes, which I know you are thinking, my God, why does he make videos so long? But this 45-minute video is meant to represent or replace 4 hours in class. So basically you could watch this video for 45 minutes, which of course you don't have to do the whole thing at once. Or you could come to class in person and watch me talk for 4 hours straight. Okay, with this one, I'm going to speed it up by using the calculator to find out where it equals 0. So you've got 30x squared plus 22x minus 6. So just find out where this equals 0. So when you go to the graph, let's see, where does it cross the x-axis? Oh, there and there. So I could tell the calculator, calculate, where does it equal 0? And to me, that answer looks like it's -1. So I just pick something on the left, like -2, pick something on the right, like 0, and then your guess, or my guess, is -1. And it turns out I was pretty close. X equals a -0.945. And then for this answer, that looks like it's a +0.1 or a +0.2. Well, just go through the same steps. Go second, calculate. Where is it equal to 0? So I'm thinking it's between 0 and 1, and my guess is a 0.2. And it says, Greg, actually you're pretty close. That is a 0.212. Okay, now we need to do one with the quotient rule. And this is the last example for today. So if you have a quotient like x over x squared plus 22. So again, where does the derivative equal 0 is the question. And for this, we need to use the quotient rule. So y prime equals, and then just make a big fraction, copy down the bottom, put parentheses and squared, and now the bottom's done. Then for the top part, you take the derivative of the top, and the derivative of x is just 1. Copy down the bottom exactly as it is. Don't forget the quotient rule has minus. And then copy down the top part just as it is, and now take the derivative of x squared, which is 2x. Now the good news is, when you have a fraction, when does it equal 0? Well, it equals 0 only if the top equals 0. Which is good news because that cuts our work in half. That means we don't even have to pay attention to the bottom. All we need is the top. So on the top right here, there's 1x squared, and this would be minus 2x squared. So negative 2x squared plus 1 is going to be negative x squared. And then there's a 1 times 22, so that means it's plus 22. And then that's the top, and then we just need to see when does that equal 0. And then since this is negative, I'm going to move it over to the right side, so it becomes a positive x squared equals 22. And the last thing I need to do is get rid of the squared by taking square root of both sides. And when you do, make sure you get the two answers by saying plus or minus. And with the square root of 22, that cannot be simplified. So you could either leave it like that, or you could find out what square root of 22 is. A 4.69. So x equals plus or minus a 4.690. And either that one or that one would be perfectly acceptable. And now we're done. And look at that. 1.5 minutes, under 45 minutes. Yahoo!